Night falls gently, and the last hues of sunset fade into a deep indigo across the sky. A hush settles over the world as daytime creatures rest and the air cools. Overhead, one by one, tiny lights appear in the darkening vault, the first stars of evening shyly peeking through the twilight. In this quiet moment, it feels as if the heavens are slowly awakening. The earliest star glimmers alone for a while, perhaps Venus, the evening star, often the first jewel to grace the dusk. Long ago, people might have greeted this star with a sense of wonder, even a whisper of reverence. It was a signal that night had truly begun, bringing with it the mysteries of the cosmos. In ancient times, far from the glare of modern lights, our ancestors gathered under these evening skies, eyes upturned in awe. Imagine a small group, hundreds of years ago, families clustered around a gentle fire, its warm glow flickering against the silhouettes of trees or desert dunes, while overhead the dome of night grew darker and richer with stars. They watched as more points of light materialized against the darkness, and with each new star, their imaginations stirred. The elders would share stories in hushed voices, telling the children that those lights above were not mere distant flames, but something more, heroes and heroines placed among the stars, gods watching over the world, or the spirits of ancestors keeping vigil from the sky. In the absence of scientific understanding, the night sky became a canvas for myth and meaning. Every pinpoint of light inspired a tale. Some said a great spirit, or god, carefully placed the stars in the heavens, one by one. Others spoke of a more mischievous origin. In a Navajo legend, the first people began arranging the stars in deliberate patterns, but Coyote grew impatient with their slow work. He grabbed the blanket full of star stones and flung it into the sky, scattering stars everywhere in a chaotic spray. Thus, the story explains, some stars form meaningful groups, while others lie scattered without reason, all because of Coyote's prank. In this way, the night sky gained both its orderly constellations and its random sparkle. Such stories gave the darkness character and personality. As darkness deepened, the faint band of the Milky Way revealed itself, a delicate, milky glow arching from horizon to horizon. Under truly dark skies, it glitters like powdered silver on black velvet, a ghostly river of light. Our forebears looked upon that shimmering band with wonder and curiosity. What could it be? To them, it seemed like a bridge between realms, or a celestial pathway. In one culture, people said it was a great river in the heavens, flowing with divine waters, or even the milk of a goddess spilled across the night. In another, it was a trail of white ash, the embers of an ancient campfire flung into the sky by a powerful being, creating a pathway of stars. Others imagined it as a road for spirits, a highway on which souls travelled to the afterlife. Each culture wove its own story around that misty band of light, but all agreed it was something sacred and extraordinary, a beacon in the darkness connecting heaven and earth. Not only the Milky Way, but each glittering star had its own significance in the eyes of ancient peoples. See how the stars sprinkle the sky in uncountable numbers, some bright, some faint, some alone, some in clusters. To the unaided eye, stars seem eternal and unchanging, tiny lanterns that magically appear at nightfall and vanish with the dawn. For early humans, these lights were both comfort and mystery. Many believed they were indeed fires, perhaps the campfires of distant travellers or of the gods themselves, glowing faintly across the vastness. It was comforting to think that just as they gathered around their fire on earth, other beings might be gathered around fires in the sky. In other traditions, people said the stars were openings, little holes pricked in the dark veil of night, letting the radiant light of heaven shine through. The sky above was imagined as a great dome or tent covering the world, and the stars were pinholes in that shelter, hinting at a glorious realm beyond, glittering through the tiny openings. Others whispered that the stars were alive, that they were ancestral spirits watching over the living. To stand under a sky full of stars was to stand among one's ancestors. Perhaps a father or mother who had passed on had become one of those stars, looking down kindly each night. In the stillness of night, one could speak in one's heart to those twinkling lights and feel a comforting presence. The idea brought solace. No one was ever truly alone under the sky, because the ancestors' souls shone down as stars. And so, what could have been a fearful darkness became instead a dome of companionship and guidance. Each twinkling point might wink as if sharing a secret or offering reassurance to those below. As the fire crackled softly and crickets sang their nightly chorus, ancient storytellers would gesture to patterns they saw among the stars. In the random scattering of lights, the human mind found pictures, connecting the dots to form figures of legend and lore. Over time, these pictures became the constellations, each with its own name and story. The night sky was like a grand storybook spread open above, filled with heroes, monsters, and sacred beings, their tales written in starlight. By naming and mythologizing the stars, our ancestors made the vast unknown feel a bit more familiar, a bit more like home. Look up with them now. High above, the sky is studded with stars beyond counting. The longer you gaze, the more appear, as if the universe is gradually revealing its full splendor. And with those stars come timeless stories, whispering through the cool night air. The stage is set, darkness all around, tiny lights shimmering in patterns, and the ancient myths are ready to unfold. Let us drift into those old, gentle tales written in the night, the better to know the dreams our forebears dreamed under these very same stars. The night sky above is not just an array of random points. It is full of patterns if one knows how to look. As your eyes adjust to the darkness, those seemingly scattered stars begin to form shapes, like a cosmic connect-the-dots puzzle. For thousands of years, humans all over the world have traced out these shapes and imagined them as figures. The constellations, each with a story to tell. These starry pictures gave order to the heavens, turning the chaos of countless lights into a rich tapestry of familiar characters and tales that could be passed down through generations. One of the most striking patterns rising in the sky is Orion. Look for 3 bright stars in a short, straight row. That is Orion's belt, the waist of the celestial hunter. Brighter stars mark his broad shoulders and knees, and an outstretched arm brandishes a shining bow or club, depending on the tale. In the stillness of the night, you can almost envision this giant figure striding across the heavens. The Greeks knew him as Orion, a mighty hunter of great prowess and pride. In their legend, Orion boasted that no creature on earth could escape him, vowing to hunt every beast. Such arrogance worried Gaia, the earth goddess, who sent a tiny scorpion to stop the boastful hunter. In the story, the small but deadly scorpion managed to sting Orion, proving even the mighty can fall. Moved by the events, the gods placed both the hunter and the scorpion in the sky as reminders. To this day, the constellations of Orion and Scorpius reside on opposite sides of the heavens. As one rises in the east, the other sets in the west. So the hunter and the scorpion never meet again. Orion dominates the winter skies, while Scorpius, with its graceful curve of stars, rules the summer nights, forever chasing each other through the seasons. But Orion's story does not end with the Greeks. Those same stars have inspired many different peoples to create their own tales. In the lands of the Pacific, far from Greece, Polynesian navigators looked up at Orion's belt and saw not a hunter, but a row of 3 points that they sometimes viewed as the outline of a great canoe or the stingray's tail. And the constellation we know as Scorpius, which stings Orion in Greek lore, was imagined very differently by the Polynesians. They saw the graceful curve of Scorpius's tail as the fishhook of the demigod Maui. According to their stories, Maui cast this giant hook into the ocean of the sky and fished up whole islands from the sea. When you gaze at Scorpius on a clear night, you can trace its long curving shape and perhaps picture, instead of a scorpion's tail, a great hook catching hold of new land beneath the waves. The star at the end of the hook, which we call Antares, a red, fiery star, to the Polynesians, was the blood on Maui's hook, or the glowing bait that entices his catch. Through this lens, the sky above the islands told of how their very lands were born, not through stinging battles, but through a clever act of cosmic fishing by a culture hero. Meanwhile, in the southern regions of Africa, different eyes looked at the constellation of Orion and wove their own unique fables. Some groups, like the Tswana, also connected Orion's stars into familiar shapes from their world. They saw the 3 stars of Orion's belt as 3 pigs, clustered together in a line, and trailing behind them, the faint, misty stars of Orion's sword, which hang just below the belt, became 3 wild dogs, chasing those pigs through the sky. In their view, the great hunter figure was instead a lively cosmic chase of prey and predators. One can imagine around a campfire on the savannah, a storyteller pointing out those stars to children, describing how the three dogs forever pursue the three pigs across the heavens each night. The children might giggle at the thought of something as ordinary as pigs and dogs in the majestic sky, but this tale would tie the heavens to their everyday life, making the night sky feel friendly and close. We can see from these stories that the same pattern of stars can inspire many different visions. To Greek eyes, Orion was a human figure, a hunter, engaged in drama with a scorpion. To Polynesian eyes, parts of Orion and Scorpius together became a tool of creation, a giant fishhook lifting islands from the sea. To some African eyes, Orion turned into animals familiar from the local landscape, and these are just a few interpretations. In other places, Orion's belt has been seen as a line of pearls, as three kings carrying gifts, or as three beautiful sisters dancing in a row. The stars themselves are neutral, but human imagination paints them with countless stories, each culture adding its own chapter to Orion's legacy. Another constellation known far and wide is the Great Bear. High in the northern sky, a large ladle-shaped grouping of stars is easily recognized. Many know it as the Big Dipper. Those 7 bright stars form part of a larger constellation the ancients called Ursa Major, the Great Bear. In Greek mythology, the Great Bear was once a maiden named Callisto. She was transformed into a bear and placed in the sky to escape the wrath of a jealous goddess. Her son, who was a hunter on Earth, nearly shot the bear, not realizing it was his mother. To save them both, the king of the gods swept mother and son into the heavens, where they became the Great Bear, Ursa Major, and the Little Bear, Ursa Minor, forever safe from harm and forever together, circling the North Star. When the Greeks looked up, they saw not just an animal, but a poignant story of a mother and child immortalized among the stars. Many Native American peoples also saw a great bear in these same stars, though their stories were different. Among some tribes, the 4 stars of the Big Dipper's bowl were seen as a great bear, and the 3 stars of the handle were hunters chasing it. One tale tells that as autumn arrives, the hunters finally catch the bear. When the constellation sinks low in the sky, they imagine the bear had been wounded, its blood falling to earth and turning the leaves red. But the bear's spirit rose back into the sky, and the chase began anew each spring when the Big Dipper, the bear and hunters climbed again above the horizon. To those communities, the cycling of that constellation through the seasons mirrored the cycles of nature on Earth, like the changing of leaves and the time of hunting. So the stars of the Big Dipper were more than a guide to north. They were actors in a recurring drama that taught lessons about respect for nature and the circle of life. Then there is the delicate cluster of stars known as the Pleiades. On a clear night away from city lights, you might notice a tiny, misty dipper of stars, like a small sprinkle of glitter on black velvet. To most people, It appears as 6 or 7 stars close together, a tiny congregation of lights. Because of its striking appearance, many cultures focused on this cluster and created tales about it. The Greeks called them the Seven Sisters, daughters of the Titan Atlas, placed in the sky for their protection. In their story, the great hunter Orion, yes, the same Orion, fell in love with the Seven Sisters and pursued them relentlessly. To save them, Zeus transformed the maidens into doves and set them among the stars as the Pleiades. But even in the sky, Orion still chases them. We see Orion and the Pleiades in the same winter sky, the hunter forever following the cluster of sisters, but never quite catching up. Interestingly, far away in Australia, Aboriginal stories also speak of a group of 7 sisters being pursued across the sky by a male figure or hunter. Despite oceans and millennia apart, people imagined a similar drama for those stars. Across the world, the Pleiades are often associated with the number 7. 7 sisters, 7 little girls, 7 sages, or 7 birds. Yet typically, only 6 stars are easily visible to most eyes. Many cultures notice this and have myths explaining why one star is missing or faint. In one Greek tale, one of the 7 sisters, Merope, fell in love with a mortal man, and so her light dimmed in shame, making her harder to see. In an African story from the Kalahari, the Pleiades were not sisters, but rather a group of girls dancing in the sky. One of them had no husband, and she shines less brightly out of sorrow. Thus only 6 glow clearly. Such tales bring personality to the stars. One is hiding or lost, or in mourning. Beautiful little details that make the night sky feel alive with characters and emotions. Of course, not every culture saw the same images. While Greeks saw 7 sisters in the Pleiades, some Native American peoples saw them as 7 fledgling birds flying after their mother, and some Polynesians saw them as a cluster of tiny eyes of fishes sparkling in the night. In Japan, the Pleiades are called Subaru, a name meaning to unite, reflecting how those stars are bound together. No matter the interpretation, this tiny cluster has been a source of fascination and comfort. It also had practical significance. The Pleiades' first appearance in the pre-dawn sky signified the coming of planting season for many ancient farmers, and their disappearance in the evening sky later in the year signified harvest time. Thus, the stars' stories were not just entertainment, but a calendar and guide for survival. All across the heavens you can find such stories. The stars of Leo were seen as a great lion by the Romans and Greeks, but to the Persians they were a regal king, and to the Chinese those same stars might have formed part of a celestial dragon or chariot in their own sky lore. Cassiopeia's 5 bright stars make a crooked W. To the Greeks, they represented a proud queen sitting on her throne, while in other lore, they have been a cosmic mountain range, or even part of a great celestial moose. And not only groups of stars inspired tales, even single stars and pairs of stars have their legends. In East Asia, for instance, the bright star Vega and her counterpart Altair are celebrated in the story of the Weaver Girl and the cowherd. They were lovers, separated by the silvery river of the Milky Way. allowed to meet only once a year, when a bridge of magpies forms across the sky. On that summer night, celebrated as the Kikshi Festival in China and Tanabata in Japan, the two stars draw close. The tale imbues those individual stars with romance and longing, turning the simple sparkle of distant suns into a touching story visible on a warm summer evening. Each constellation and star myth is a reflection of the people who imagined it, tying the sky to their landscape and values. These stories were whispered under open skies in the desert, sung around fires on the beach, or taught by elders pointing to the stars from a snowy hillside. Through them, people found a way to make sense of the stars' patterns, to bind the unknowable vastness of space into familiar sagas. Under the blanket of night, telling these tales, people everywhere could feel a profound connection to the cosmos. Above every land, the sky told a story that featured the landscapes, animals, and heroes of that culture, a reflection of themselves in the stars. As you let your eyes wander among the constellations, imagine all the eyes that have gazed at those same star patterns before you. The pictures we see might differ, but there is a shared human experience in finding shapes in the sky and attaching meaning to them. In a very real sense, the constellations are bridges. They link us to our ancestors who told these stories, and they link one culture to another through the common act of stargazing. Even if the tales vary, the wonder is the same. One can feel it across time. A parent in ancient China pointing out the stars to an eager child. A traveller in the Sahara following the outline of a heavenly animal. A sailor on the Mediterranean recalling a myth to navigate by the stars. All felt that mix of awe and familiarity. These star patterns made the night sky a friendly, navigable place. They turned distant, burning suns into familiar friends and eternal guides watching over the world. And yet, as rich as these starry tales are, the cosmos has still more wonders beyond the stars themselves. For amid the constellations, if you look closely, you may notice a different kind of heavenly light. Not a sharp pinprick, but a gentle, hazy glow. Ancient sky watchers saw only a few of these mysterious smudges of light in the darkness, and often didn't know what to make of them. Now we understand them as nebulae, immense clouds of gas and dust, the nurseries of new stars. Let us leave behind the patterns of familiar stars for a while and venture into the realm of these ethereal, cosmic clouds. Gazing beyond the constellations and bright stars, we find that the night holds softer glows as well. Not everything in the sky is a sharp pinprick of light. There are places where the starlight seems to blur into a gentle haze, forming faint clouds that float among the stars. Early star watchers noticed a few of these ethereal patches. The Persian astronomer Abd al-Rahman al-Sufi, in the 10th century for example, recorded a small cloud in the Andromeda constellation, the earliest known observation of what we now realize is an entire galaxy beyond our own. But to those without powerful tools, these wisps were mysteries. Was it a trick of vision? A a cluster of many stars, too small to separate, or something else entirely. Without the means to see deeper, our ancestors often folded these nebulous lights into their myths, or simply admired them as peculiar oddities. Today, with the aid of telescopes and modern understanding, we know these gauzy patches for what they are: nebulae, vast cosmic clouds of gas and dust adrift in the galaxy. The word nebula comes from Latin, meaning cloud, and indeed they are like clouds, only these clouds hang light years wide in the vacuum of space. They are tenuous, many million times more diffuse than any cloud on Earth, yet from afar they can glow beautifully. Some nebulae shine with a faint light of their own, lit from within by newborn stars, like lanterns in a fog. Others are visible only because they reflect the glow of nearby stars, or because they stand as dark silhouettes, hiding the stars beyond. Through a telescope, what once looked like a mere blur reveals itself as a delicate splash of colour and shape. Cosmic clouds in shades of rose and blue and violet, swirled and feathered by stellar winds and radiation. One of the most famous of these cosmic clouds lies in Orion, the very constellation we just explored through legend. Hanging beneath the 3 stars of Orion's belt is a region the ancient Greeks marked as Orion's sword. To the unaided eye, one star in that sword looks a bit fuzzy. That is no star at all, but the radiant mist of the Orion Nebula. Aim a small telescope, or even steady binoculars at it on a dark night, and you begin to see it is not a point, but a softly glowing cloud, a tiny patch of brightness with a gauzy halo. In long exposure photographs from large observatories, the Orion Nebula blossoms into a breathtaking vision, a great billowing cloud of luminous gas and dust, tinted with subtle hues of red and green and purple. Its appearance has been likened to a cosmic blossom or a celestial flame. Bright young stars embedded in the nebula light up the gas around them, causing the cloud to fluoresce gently like a neon mist in space. If you could fly closer to the Orion Nebula, you would find yourself drifting through a realm of gentle radiance. All around you would be thinly spread gas, so faint you might not feel it at all, yet visibly aglow in every direction. You might see filaments and streamers of translucent material stretching out like gossamer curtains. Deeper inside, there are cavities and pillars sculpted by starlight, niches where the light of newborn stars has cleared away the dust around them. At the very heart of the nebula, a cluster of infant suns, known as the trapezium cluster, shines brilliantly, only a few million years old. Their combined glow is like a cosmic campfire, illuminating the swirls of the nebula and revealing the cloud structure to the universe. It is poetic, then, that long before modern astronomers unveiled the Orion Nebula's secrets, the Maya people of Central America looked at this part of the sky and imagined the spark of creation itself. In Maya tradition, the 3 bright stars in Orion's midsection were seen as the 3 stones of a hearth, the foundation of a sacred fireplace in the sky, and the faint smudge of the Orion Nebula. They perceived it as the glow of the cosmic fire, the smoke of creation, rising from the heavenly hearth. To the Maya, this spot marked where the first fire was lit at the beginning of time. In a beautiful coincidence, we now understand that the Orion Nebula is indeed a place of creation, not of human life, as the myth suggests, but of stars. The Maya, through their imagination, had symbolically identified one of the galaxy's great stellar nurseries as a genesis point. When we observe the Orion Nebula today, we can appreciate it on two levels. As the scientifically wondrous stellar nursery it is, and as the fulfillment of an ancient story about cosmic birth. The nebula's gentle glow can be seen as both the literal light of new stars forming and the figurative hearth fire of creation that our ancestors sensed in their mythology. Nebulae come in many forms, each with its own subtle beauty. Some are vast and diffuse, like the great nebulae in the constellations Carina and Sagittarius, where torrents of star formation are taking place behind curtains of interstellar dust. Others are small and ring-shaped, the ghostly remains of dying stars that have gently shed their outer layers, forming structures like the Ring Nebula or the Helix Nebula, often called the Eye of God for its striking appearance of a blue eye peering out of the darkness. There are nebulae shaped like crabs, like horses' heads, like roses and butterflies. Fanciful names given by astronomers who, much like the storytellers of old, cannot help but see familiar shapes in these clouds. Through modern telescopes, we have captured astonishing images of the Eagle Nebula, where towering pillars of dark dust stand silhouetted against glowing gas. Structures so dramatic they were nicknamed the Pillars of Creation. In those pillar-shaped clouds, new stars are being born behind veils of dust, hidden from our direct view. At the sight of those pillars of creation, many were struck by how nature's processes evoked the imagery of sculpture and myth in our minds. It seems that even now, as we peer into the galaxy, our minds reach for metaphors to make sense of what we see. A horse's head, an eagle, a flame. The language of myth and imagery lives on in the way we describe these wonders. Of course, lying out under the stars, you will not see those vivid colours and shapes with just your eyes. Human vision isn't sensitive enough in the dark to catch the hues of nebulae. To us without equipment, these cosmic clouds appear as pale, ghostly patches, there and not there, revealed only when we gaze long and attentively. This is part of their magic. Nebulae are subtle, requiring patience and curiosity to appreciate. But once revealed, even faintly, they expand our perspective of the night. Between the pinpoint stars that seem so fixed and eternal, we discover these dynamic clouds, places where the cosmos is actively creating and recycling. The elements spreading out in a nebula, hydrogen, helium, and trace elements like carbon, oxygen, iron, are the raw ingredients for future suns and planets, even for life. In those nebulous expanses, All the material that can one day form new worlds is floating and drifting, waiting for the next chapter of the cosmic cycle. Think of it. In the subtle glow of a nebula, we are witnessing a chapter of creation. The same kind of cloud that is now lighting up in Orion will, over millions of years, collapse and condense into bright new stars, perhaps encircled by their own planets. In a very real sense, nebulae are the wombs of the galaxy, the places where the universe renews itself by birthing new stars. Every star you see in the night sky, at some point long ago, was born in a nebula like these. And every nebula is a promise that the story of starlight will continue, that new stars will keep on rising to replace the old. Under the calm, unhurried canopy of night, let your mind drift to one of these distant, glowing clouds. Envision the soft radiance and the delicate tendrils of luminous gas stretching for trillions of miles. Within those clouds, tiny seeds of stars are taking shape, as we will soon witness. The nebula cradles them, cushioning them in cosmic dust and gas, until they grow dense and hot enough to shine. Here in these cosmic nurseries, creation is quietly unfolding on the grandest of scales. Our journey now carries us deeper into the very process that makes the nebulae so meaningful. It is one thing to float amidst these stellar nurseries. It is another to witness the birth of a star itself. But in our imagination, we can do just that. Let us gently follow one of those contracting knots of dust and gas hidden within a nebula. We will watch it shrink and glow and eventually burst into light as a new star is born. In the secret heart of a nebula, where starlight is dim and diffused, a small miracle is taking shape. Here, a clump of gas and dust, barely discernible from its surroundings, begins to draw itself together. Gravity, the same gentle force that causes an apple to fall to the ground, is at work on a cosmic scale. It tugs ever so persistently on that clump, pulling the particles inward, closer and closer. At first the process is imperceptible, a slow tightening of the cloud. Over years and centuries and millennia, the cloud's diffuse glow intensifies in its center, a sign that something is happening deep inside. We wait in the silence of space as ages pass. The cloud fragment becomes denser, turning from a transparent haze into a concentrated, opaque knot. As it contracts, it starts to spin ever so slightly, like a dancer pulling in her arms and twirling faster. Around the growing core, a flat disk of leftover material forms, swirling like batter in a bowl. The material near the center continues to compress under its own weight. What was cold and dark begins to warm and glow dull red. The gas atoms jostle and collide more rapidly as the space around them shrinks. In time, long stretches of time far beyond human scales, the heart of this gathering protostar grows hot and incredibly dense. Imagine being in the midst of this process. Though it unfolds over tens of thousands, even millions of years, If we could speed up time in our mind's eye, we would see the cloud swirling and tightening, and a brightening point emerging at its heart. We might observe thin jets of energy and matter spurting from the protostar's poles, twin beams ejecting excess energy like a newborn's first cry announcing its arrival. They stream out for a short time as the star gains definition, then quiet down as the infant star stabilizes. Inside the shrinking core, the temperature climbs relentlessly. The protostar is still hidden in its dusty womb, but it's on the verge of a dramatic transformation. When the core temperature reaches a critical point, on the order of millions of degrees, a profound change occurs. Hydrogen atoms begin to fuse together to form helium, and in doing so, release a tremendous burst of energy. This is the spark of starlight. What was once just a cold, dark clump now becomes a newborn star, igniting with its own light and heat for the first time. It might start modestly, a weak glow suffusing the surrounding cloud, but it does not take long for the new star to assert itself. The protostar's shroud of dust and gas is pushed outward by the emerging light, and by winds of charged particles streaming from the hot new surface. Gradually, the surrounding cocoon is blown away, or falls into the star, clearing the view. The moment of first light has truly arrived. A soft new star beam pierces the veil of the nebula. From within the cloud, a star is born, and its radiance can no longer be contained. The darkness that dominated this little corner of space is banished by a brilliant presence at the center. What was once merely an accumulation of drifting dust now shines with a steady, growing flame. The young star's light spills into space, illuminating the remnants of its birth cloud from within. If there were observers far away, they would now see a new pinprick of light that wasn't there before, adding to the multitude of stars in the sky. Around the newborn star, the formation process leaves behind a living scene of cosmic artistry. That disk of leftover gas and dust still circles the star like a halo. Within it, matter is beginning to clump together. Tiny grains of dust stick to each other, forming pebbles. Pebbles gather into rocks. Rocks attract more material and grow into nascent asteroids or planetesimals. Over millions of years, these could become planets that will orbit the new sun. Whole new worlds taking shape in the afterglow of the star's birth. In some sense, the star is a parent, and the disk its cradle for offspring planets. For now, though, all of that is just beginning. The main event is the star itself, blazing with newborn energy. Our own sun was once just such a protostar, born in a cloud that formed many sibling stars. Billions of years ago, it emerged from its nebula, lit up, and the planets, including Earth, coalesced around it in its disk. Every twinkling star we see went through a similar infancy. Each is the product of gravity and time, turning diffuse matter into dazzling light. In a way, the nebula is like fertile soil, and the stars are the blossoms that bloom from it, fueled by that rich mixture of elements until they ignite in brilliance. Back in the Orion Nebula, we imagined earlier, many stars are being born in parallel. Our focus has been on one, but dozens of others are flickering to life in that single cloud, forming a new cluster. Some will be massive, shining blue-white and living brilliant but short lives. Others will be small and red, glowing gently for trillions of years. They all push away the nebula material around them, carving out cavities in the cloud like hot knives through mist. Eventually, these infant stars will disperse the nebula that gave them birth, uncovering themselves to the wider galaxy. The nursery will fade away, and the stars will drift into the galaxy, each going on to live its own journey among the myriad others. For the one star we followed, now comes a time of relative peace. What was a turbulent, chaotic birth settles into a long, steady adulthood. The star joins the grand stellar family that populates the universe. It will spend eons quietly fusing hydrogen into helium in its core, radiating warmth and light into the cosmos. Perhaps it will have planets circling it, and perhaps on one of those planets, in some distant epoch, there might be beings who look up at this star with the same wonder we reserve for our own guiding stars. They may give it a name, tell stories about it, or use it to navigate their way across unknown lands or seas. From our vantage point here and now, we consider that new star simply another point of light in the firmament. But knowing what we know, we can appreciate the incredible journey it underwent to shine for us. It came from cold darkness, and, through the slow choreography of physics and time, burst into light. It is truly a journey from dust to light, a transformation as magical as any myth, yet tangible and real. The new star will shine steadily for eons, one more beacon added to the sky. Where there was darkness, now there is light, a tiny sun born from the cloud, ready to take its place among the stars of the night. Now we return to Earth, beneath the endless dome of stars, to reflect on how these celestial lights have guided and comforted humanity throughout history. For as long as we have walked the earth, the stars have been our compass, our calendar, and our inspiration. They are the silent guides that have pointed the way when we ventured into the unknown, and the faithful friends that reassured us in the dark. Consider the ancient mariners setting sail across open oceans, long before the age of GPS or even the magnetic compass. Imagine a Polynesian navigator in a wooden canoe, the sea breathing gently around him under a sky brimming with stars. He has no maps on paper. His map is in the heavens. The tropical night sky above him is so clear that the band of the Milky Way glows and reflects on the dark water below. The gentle trade winds fill his sails, and bioluminescent plankton sparkles in the wake of his canoe, as if the stars themselves are drifting in the sea. The navigator feels a deep calm. He is cradled between the starry sky and the ocean, guided faithfully by those lights. As night falls, he watches the constellations rise and set. He knows each star by name and remembers their seasonal paths. To voyage from one island to another hundreds of miles away, he aligns his canoe with a certain star that hangs just above the horizon, steering by its position. All night, that star beckons him onward over the waves. When it sets, he knows another will rise in its place to continue guiding him. In his mind, the sky is divided into segments, a star compass, telling him which direction he's heading. The stars are trusted allies. With them, he can navigate to tiny targets of land in a vast ocean. As he looks up, he feels not alone, but accompanied by a whole glittering navigation chart drawn by the gods. Under their light, he finds his way home. Far across the world, picture a caravan of traders crossing the Sahara Desert in medieval times. By day, the sun scorches the dunes and the path is hard to trace. So they choose to travel by night. The desert night is cool and quiet, the great silence broken only by the soft tread of camels on sand and the occasional jingle of a harness. Overhead, the sky is magnificent. In the dry air, stars shine with a steady brilliance. In the far southern hemisphere, where Polaris cannot be seen, travellers instead look for the distinctive Southern Cross to find south. But here in the Sahara, the caravan leader finds Polaris, the North Star, shining with a modest but unwavering light. In those northern latitudes, Polaris stands almost due north, barely moving through the night. The caravan turns toward that constant star as a guide. Step by step, camel by camel, they traverse the featureless sands, using the sky as their map. There are no landmarks in the shifting desert, but Polaris and the familiar constellations give orientation. As the hours pass, the leader occasionally checks the two stars at the end of the Big Dipper's bowl, which point like an arrow to Polaris, confirming he has the right star. Comforted by that celestial signpost, the travellers know they are not lost. The night may be vast and dark, and the dunes ever shifting, but the stars provide a sense of direction and a promise that the world beyond the horizon has order. On the deck of a sailing ship in the Atlantic centuries ago, a navigator lifts his sextant toward the sky. The ship rocks gently on the waves as he takes a measurement, the starlight flickering in the ripples of sea water below. For a moment, he pauses and gazes around. The night is so clear that stars not only fill the sky, but seem to touch the horizon in every direction, wrapping the ship in a celestial sphere of light. It is as if the vessel is sailing through the stars themselves. With a steady hand, he resumes his measurement. After consulting his charts, he determines his latitude. The star has quietly told him how far north or south he is. Countless explorers and sailors did this, relying on the heavens to guide their journeys. For them, a cloudy, starless night was dreaded, but a clear, starry night meant reassurance and direction. Even the slaves fleeing bondage in the American South looked to the stars for guidance. They followed the drinking gourd, the Big Dipper, as it circled around toward the North Star, using it to navigate their path to freedom under cover of darkness. Even other creatures of the earth have navigated by the skies. Certain migratory birds orient themselves by star patterns, and even dung beetles have been shown to use the pale light of the Milky Way to roll their balls in straight lines. Navigation by starlight, it seems, is a universal strategy in nature. The guidance of stars wasn't only for travel. In many cultures, people set their calendars by the heavens. The ancient Egyptians waited for the heliacal rising of Sirius, the moment it first became visible at dawn after months of being hidden by the sun's glare, because it signaled the imminent flooding of the Nile and the start of a new year. The stars told them when the life-giving waters would return. They even aligned some of their greatest monuments with the heavens. Some studies suggest the 3 pyramids of Giza were positioned to mirror the belt of Orion, integrating their spiritual beliefs with the starry sky. Across the world, many temples, tombs, and monuments point towards certain stars at specific times of year, as if to anchor human life to the cosmos. Farmers around the world have also looked to the sky for guidance. The appearance of certain stars at dawn or dusk told them when to plant or harvest. For example, the rising of the Pleiades before sunrise in spring signaled planting season in parts of Greece and Italy, while their setting in autumn signaled harvest. Such celestial signs were like the ticks of a great cosmic clock. To see your familiar seasonal stars return was to know that the cycle of time was turning as it should, giving a comforting predictability to life. Beyond these practical uses, the stars have always given us psychological comfort and a feeling of connection. Think of a lonely traveller in ancient times, perhaps a poet or pilgrim on a long journey between far-flung villages. At night, he rests on a hillside and gazes upward. He sees the same pattern of the Great Bear or Orion that he recognized at home. Though he is far from his loved ones, the sight of those constellations brings a sense of familiarity. He knows that his family back home can look up and see the very same star he is looking at that moment. In that realization, distance shrinks. They are together under one sky. The phrase, "we are all under the same stars," has reassured many separated friends and lovers through the ages. No matter how far apart, they could find comfort in knowing they share the stars each night. Under the starry sky, one cannot help but feel a sense of perspective. Generations have come and gone, but the stars remain, shining on all who look up. Ancient Romans saw the red star Arcturus in the spring sky, and new planting time had come. Thousands of years later, we see that same star and feel the warming winds of spring. The stars create an invisible bond between past and present. When we gaze at them, We are participating in a tradition as old as humanity itself. Around the world, elders taught children to recognize constellations, to navigate, to tell time by the stars. This knowledge was a gift passed down, and with it came a sense of stability. The stars change so slowly that to human eyes they are essentially permanent fixtures. In a chaotic world of changing fortunes, the night sky was a reassuring constant. Even today, in our era of bright cities and technology, the sight of a clear night sky brings profound peace to many. Perhaps you have experienced a moment when a power outage suddenly revealed a sky full of stars, usually hidden by city lights, and felt a surge of awe and comfort. In the countryside or wilderness, away from the glare of urban life, a traveller who looks up at the undimmed Milky Way might feel almost overwhelmed by its beauty and enormity. Yet along with that comes a deep sense of belonging and calm. In those moments, we experience the same awe and solace our distant ancestors felt. There is a humility in it, recognizing our smallness in the face of the cosmos, but also a warmth, a feeling that the stars are friendly, watching over us while we sleep. Modern science has added another layer to our connection with the stars. We now know that the elements in our bodies were forged in the hearts of ancient stars that lived and died before the Earth was born. The calcium in our bones, the iron in our blood, the carbon in our cells. Those atoms were formed in stellar furnaces and scattered across the galaxy when those stars exploded long ago. Our very existence is tied to the life cycle of stars. In a literal sense, we are made of stardust. When we look up at the stars, we are gazing at our cosmic ancestors. Perhaps this is why it feels so natural, so right, to find guidance and meaning in them. Subconsciously, we recognize that we are part of this universe, made of the same matter and energy, and the stars are our kin. As the night deepens and you lie under the sky, you might feel the weight of these ideas gently settle in your mind, not as a burden, but as a comfort. The stars above are constant companions. Polaris still points north, as it did for navigators long ago. Orion still heralds the winter, and Sirius the summer. The Pleiades still disappear and return with the seasons. Though we no longer depend on them for navigation or agriculture as intimately as we once did, their presence is as reassuring as ever. They remind us that some things are enduring and dependable. Now our journey through this first part of the night's wonders comes to a soft close. We have travelled from nightfall and ancient myths to constellation legends across cultures, from glowing nebulae in the depths of space to the birth of a star, and finally back to the guiding lights that have always watched over us. The fire of creation in distant nebulae eventually becomes the gentle twinkle of a star in our sky, a star that might guide someone home or simply bring a spark of wonder on a quiet night. The cycle is beautiful and unending. As you close your eyes or simply rest in the darkness, imagine those stars still above, shining down with their cool, patient light. They are the same stars that guided lost wanderers to safety and inspired wise ones to ponder the heavens. In their silent way, they promise that dawn will come, and that we are never alone under this expansive sky. Our exploration of the cosmos will continue, for there are countless more marvels beyond the horizon of night. But for now, in this gentle pause, we can be content knowing that the stars will keep their watch, lighting our way in the darkness and linking our dreams to the vast, friendly night. We drift in the gentle darkness of space, surrounded by a countless array of stars. They sprinkle the cosmic landscape like distant lanterns, each one a sun with its own story to tell. They were born in cosmic nurseries, vast clouds of dust and gas that slowly collapsed under gravity, igniting each star into life. Far from the noise of any world, here in the silent void, their light reaches us across the ages. Some of these stars shine with a fierce blue-white intensity, while others glow softly with a faint red hue. In this tranquil expanse, we begin to sense that not all stars are the same. Each lives its life at a different rhythm, some in slow motion and others in a brief, brilliant flash. Floating closer to one of the faint red stars, we find it small and unassuming. Its reddish light is dim, painting the surrounding space in a gentle crimson twilight. This is a red dwarf, one of the most common types of stars in the galaxy. It burns its nuclear fuel so slowly that it will shine on for what seems like eternity. In cosmic terms, these little stars are extraordinarily long-lived. We could watch this star for billions upon billions of years, and it would hardly change at all. In fact, red dwarfs like this are known to survive for trillions of years, longer than the current age of the universe. The universe itself is not yet old enough for even one red dwarf to have completely burned out. They are the quiet, enduring companions of the cosmos, patient and steady, glowing with a soft light through the eons. If there were a planet orbiting this red dwarf, its sky would be bathed in an endless sunset glow. The star might never rise brighter than a dusky ember, casting a perpetual gentle dusk over the landscape. Life, if it could exist there, would experience an eternal, calm evening under the star's faint warmth. Leaving the red dwarf behind, we drift toward a brighter star in the distance. Its glow intensifies from amber to golden white as we approach. This star is more like our own sun, a yellow-white star, larger and hotter than the red dwarf, but far gentler than the most massive stars. Its light is warm and steady, illuminating any nearby worlds with a nurturing radiance. Stars like this can live for many billions of years. Our sun, for instance, is about 4.6 billion years old and roughly halfway through its life. It is expected to shine about 10 billion years in total before it significantly changes. In the vast timeline of the universe, such a lifespan is moderate. a comfortable middle age for a star. This sun-like star has been shining for ages already, converting hydrogen to helium in its core, quietly balancing the outward push of energy with the inward pull of gravity. We bask for a moment in its life-giving glow, imagining how its warmth might feel on our faces if we stood on a nearby planet. A nearby world would experience day and night much like Earth, with a bright, stable sun rising each morning. For now, the star is stable and content, a glowing beacon of life in the dark, silently burning its fuel in a long, steady shine. As we continue our journey, we notice in the far distance a star that outshines all others around it. Its light is a brilliant blue-white, so intense that even from afar it casts sharp shadows. We venture closer cautiously as the radiance grows. This is a giant among stars, a massive blue star, many times more massive than the sun. It burns incredibly hot and bright. Its surface seethes at tens of thousands of degrees, giving it that bluish-white glare. In terms of color and temperature, this star is at the opposite extreme of the red dwarf. Blue stars are much hotter and more luminous. Up close, this star would be blinding, its energy output immense, far beyond the small red dwarf we encountered earlier. The space around it is flooded with fierce ultraviolet light and intense stellar winds of charged particles streaming away from its roiling surface. This magnificent star lives in the fast lane of cosmic existence. Because it is so massive and burns its fuel so ravenously, its life will be astonishingly short compared to the little red dwarf, where the red dwarf may survive for trillions of years. This blue giant might last only a few million. It is a transient, splendid fire, destined to exhaust its fuel quickly and end dramatically. If a planet were orbiting this star at a safe distance, the star would dominate its sky, blazing day and night with a stark blue-white light. Any nearby world would be illuminated by an eternal noon, likely barren under the star's fierce energy. We pause in awe at the contrast before us. The universe hosts stars at both extremes, the tiny red candle that never seems to go out, and the great blue beacon that flares brilliantly, but briefly. It is as if the cosmos delights in this variety of stellar beings. A thought comes to mind. The brightest flames burn the fastest, while the smaller, gentler lights endure the longest. Here, in front of our eyes, that truth plays out on an unimaginable scale. The blue star's vibrant life will be like a short-lived fireworks display in the sky, while the dim red dwarf remains an almost eternal ember glowing quietly through the cosmic night. Both have their place in the grand tapestry of the universe. Such colossal stars as that blue giant are cosmic rarities, few and far between compared to their smaller kin. For every one of these hot, short-lived titans, there are countless smaller stars, like red dwarfs, scattered throughout the galaxy. The universe is, in fact, populated most numerously by those unassuming faint stars, like a vast ocean of tiny lights with only scattered beacons of great brilliance. The massive stars may capture our attention with their ferocious glow, but the little stars are the ones who endure, quietly sustaining the background light of the cosmos for epochs untold. It's a beautiful balance. The rare, radiant giants burn out quickly, while the humble, enduring stars keep watch over the galaxies for eons. On a dark night, from some planet's surface, one might mostly notice the few big stars that shine bright. The multitude of red dwarfs would be invisible to the naked eye, lost in the background. Yet it is those countless faint stars that collectively hold the galaxy together with their steady glow. Most stars, including our Sun, spend the majority of their lives in a calm and stable phase. They steadily fuse hydrogen into helium in their cores, shining gently for millions to billions of years. This is often called the main sequence stage of a star's life, a long, serene adulthood in stellar terms. During this time, the star changes very little from one eon to the next. It provides steady light and warmth, perhaps nurturing planets, if any circle around it. From afar, its glow appears constant and unwavering, and indeed, for any human timescale, it essentially is. We could watch a star like this for 100 human lifetimes and notice no change at all. It would rise and set each day with the same reassuring brightness, as though it might shine forever. Yet even the longest-lived star must eventually move on to a new phase. Stars, like living creatures, go through a cycle: birth, a long steady life, and finally, an old age. We have seen how greatly the length of that life can vary depending on the star's size and mass. But what happens when a star's long middle age comes to an end? What does old age look like for a sun? Here in the stillness of space, we have the freedom to explore that next chapter of the stellar story. For eons, our sun-like star has been quietly shining, but deep in its core, change is slowly brewing. Eventually, after billions of years of steady light, this star will begin to exhaust the hydrogen fuel at its center. The equilibrium it maintained for so long will start to falter. When a star's core runs low on hydrogen, it's like the heart of a fire running out of wood. It begins to waver and shift. The core, now mostly helium ash from eons of fusion, starts to contract under its own weight. As it contracts, it heats up, and a shell of hydrogen just around the core ignites into fusion. This new surge of energy pushes against the star's outer layers. The star cannot hold on to its previous size. It begins to expand outward. The star's life story is taking a new turn, one that we are about to witness. We bid farewell to the steady golden star of its youth and prepare to observe the graceful transformation that will overtake it as it grows old. The quiet life of this star is about to lead into a final, beautiful blossoming before the light ultimately begins to fade. In the cosmic sea around us, there are many stars undergoing this change, if one knows where to look. Aging suns starting to swell and redden, preparing to shed what they can no longer hold. Now, let us drift alongside our star as it enters the twilight of its years, where a gentle and poignant metamorphosis will unfold in the silence of space. Time flows swiftly now as we accompany our aging star into its final stages. The star that was once a steady golden sun is swelling before our eyes. Over thousands and millions of years, it balloons outward, growing larger and larger. Its color shifts from yellow-white to orange, and finally to a deep red. The transformation is breathtaking. The star has become a red giant, a bloated version of its former self. Its outer layers have expanded far into space. If this were our own sun undergoing the change, it would swell beyond the orbit of Mercury and Venus, perhaps even reaching toward Earth's orbit. Any inner planets that once circled it would be scorched and likely swallowed up entirely in the star's fiery embrace. In this imagined far future scenario, the sun that once gently warmed our planet would fill much of the sky, a massive crimson orb overhead. The sight would be both magnificent and eerie, an enormous red sun dominating the heavens, casting a dusk-like glow over everything. Up close, a red giant is very different from the star it was in its youth. Its outer envelope is hugely expanded and tenuous. The gas near its surface is thin and cooler than it was during the star's prime. That cooler surface gives the star its ruddy colour, but though the surface is cooler, the star as a whole is far more luminous now because of its sheer size. It may be hundreds of times wider and thousands of times brighter than it was during its stable years. The star's core has contracted and grown incredibly hot, now fusing helium into heavier elements, while its outer layers have puffed out, held only loosely by gravity. The star often becomes unstable, shimmering and pulsating as it tries to find balance. It might brighten and dim over long periods, each pulsation like a slow, deep breath. During these oscillations, the star's outer layers are lifted further into space. Over time, the red giant cannot hold on to its bloated outer atmosphere. A gentle stellar breeze begins to carry away the star's substance. With each pulsation or flare, more of the star's outer gas drifts off. The giant star is effectively shedding its skin. Eventually, these drifting outer layers form a glowing cloud around the star. The star has cast off a significant portion of itself, creating an expanding envelope of gas that moves outward into the void. What remains at the center is the hot heart of the star, now exposed. The core has become a small, incredibly dense orb called a white dwarf. This white dwarf is extremely hot, tens of thousands of degrees, and it pours out intense ultraviolet light. That radiation energizes the surrounding cloud of cast-off gas, causing it to glow in rich colors. We now see a luminous nebula enveloping the dying star. Astronomers call this a planetary nebula. The term is a bit of a misnomer. It has nothing to do with actual planets, but early astronomers thought these round gas clouds resembled planetary disks when seen through small telescopes. In reality, it is the star's final halo, as if the star has breathed out a magnificent smoke ring into space. From a distance, such a nebula appears as a delicate, multicolored shell around a tiny central star. It may take on exquisite shapes that rival works of art. Some planetary nebulae look like glowing rings, as though the star blew a perfect smoke ring before fading. Others are more complex, twin lobes of gas stretching out like the wings of a butterfly, or intricate filaments twisting in space like cosmic lace. One famous example is the Ring Nebula in the constellation Lyra. It appears as a luminous smoke ring in the darkness, the peaceful remnant of a star that once resembled our sun. Our star's nebula expands outward, thinning as it grows, but for a while it remains a gorgeous, glowing bubble. Hues of soft red, blue, and green light can be seen, corresponding to elements like hydrogen, oxygen, and nitrogen in the gas. Against the black backdrop of space, it is a breathtaking vision, a fragile neon bubble that was once the outer layers of a star. At the center of this expanding nebula, the white dwarf core shines like a solitary diamond. It is incredibly small, roughly the size of Earth, yet contains much of the star's original mass. In our mind's eye, we approach it and marvel at its properties. A teaspoon of white dwarf material would weigh tons. It's extremely dense, though not as dense as the neutron star we will encounter later. For all its mass and heat, the white dwarf is only a fading ember of the star it used to be. No more fusion fires burn in its core. It shines from residual heat, slowly cooling with each passing millennium. As the eons progress, the white dwarf will cool and dim, turning from white hot to yellow, then red, and eventually becoming invisible as it sheds the last of its light. After an almost unimaginable span of time, it will become a black dwarf, essentially a cold, dark cinder of a star. The universe is still not old enough for any black dwarfs to exist yet, since even the oldest white dwarfs are still cooling. In fact, as a white dwarf cools, its carbon core can crystallize, essentially turning into an enormous cosmic diamond floating in space. All around this tiny star, the cast-off layers continue to drift outward. Eventually, the beautiful nebula will disperse, its gases mixing with the interstellar medium of the galaxy. But those gases carry the elements that the star forged in its lifetime: carbon, nitrogen, and others, seeding the surrounding space with material that will one day become part of new stars and planets. The death of this sun thus enriches the galaxy, contributing to the ongoing cycle of cosmic life. We float quietly through the remnants of our star's life, awash in the soft glow of the nebula. It is peaceful here. The fury of nuclear burning has subsided, and what remains is tranquility, stardust gently expanding, and a small core quietly shining. The star's long life ended, not with a violent bang, but with a gentle sigh, leaving a wistful beauty in its wake. For many stars, this is how the story concludes. In serene splendor, gradually dimming into the dark. Yet not all stars go so quietly. There are others, far more massive than our Sun, whose fate is to end in a spectacular explosion. For those titans, old age does not bring a graceful fading into a nebula. Instead, it triggers one final, colossal outburst. The calm ending we have witnessed here stands in stark contrast to the dramatic demise of a giant star in a supernova. Leaving behind the peaceful glow of this fading sun, we now turn our attention to a star that dies with unrivaled fury. The supernova, a stellar explosion that rocks the cosmos. We now venture to witness a far more violent end. In a distant region of space, a star much more massive than our Sun is nearing the end of its life. This star has become a red supergiant, a swollen, colossal star, hundreds of times larger than its original size. Its once brilliant blue-white glow has softened to a deep crimson hue as it expanded and cooled at the surface. Deep inside, the star's core has fused elements into heavier and heavier nuclei. Now, iron has accumulated in the core, the final element that spells doom for a massive star, since no energy can be gained by fusing iron. The star has reached a dead end. It is living on borrowed time, and a dramatic finale is imminent. In our own galaxy, the red supergiant Betelgeuse in the constellation Orion is in such a late stage of life and is expected to explode as a supernova within the next 100,000 years or so, a relatively short time astronomically. One day, perhaps far in the future, our descendants may witness its brilliant demise in Earth's sky. For a moment, the red supergiant still appears peaceful, shining in the night of space with a steady ruby light. Then, suddenly, and without warning, the star's core collapses inwards at nearly a quarter of the speed of light. In less than a second, the immense pressure crushes the core from the size of a small Earth-sized ball to a sphere only a few dozen kilometers across. This collapse happens so quickly that the star's outer layers haven't yet had time to react. But when the core can collapse no further, it recoils like a spring. A powerful shock wave is unleashed, blasting outward through the star. In that fraction of a second, the star's fate is sealed. What happens next is extraordinary. The star's outer layers are violently expelled into space. From our vantage point, at a safe distance, we see the star suddenly blaze with incredible intensity. One moment, it was a brilliant red giant, and the next, it becomes as bright as an entire galaxy. It's as if a billion suns have ignited at once where one star used to be. For a brief time, this dying star releases more light than all the stars in its galaxy combined. The supernova has arrived. Despite the unimaginably powerful explosion unfolding, here in the vacuum of space, it occurs in utter silence. There is no sound, no roar or boom, only a silent flash that illuminates the cosmos. We watch in awe as the star's layers, now incandescent, billow outward in all directions. A shell of stellar material is racing into the dark at thousands of kilometers per second. In mere hours, the star that stood for millions of years is torn apart and scattered across space. As the initial blinding flash begins to subside, the structure of the aftermath comes into view. The ejected stellar material forms an immense, billowing nebula, a supernova remnant. It is a hot, expanding shock front of gas, racing outward and ploughing into any surrounding interstellar gas. We see tendrils and filaments in the cloud, formed as different layers of the star mix and tangle. The colours are intense, hot, bluish-white near the centre where temperatures are highest, and reddish hues along the cooler, expanding edges. The display is like a cosmic firework frozen in time, blooming outward in slow motion. Within this chaotic cloud, new elements are being forged. In the incredible heat of the supernova, elements heavier than iron are created. Gold, silver, iodine, uranium. A whole treasure trove of atoms is fashioned in the crucible of the explosion and flung outward to be seeded into the galaxy. The dead star's final act is to manufacture and distribute the raw materials for future worlds. We think back to our gentle red giant and its planetary nebula. That event scattered some elements too, but it is these supernovae that truly enrich the cosmos with the heaviest of elements. In this moment, the calcium that will form bones, the iron that will carry oxygen in blood, the silicon in rocks, all are being cast into space to someday become part of new planets, new life. It's humbling to realize that the iron in our blood was once inside a star that exploded long ago. We are quite literally made of star stuff, born from cosmic alchemy like this. The expanding blast wave continues to move outward, and if there are any nearby interstellar clouds, this shock will compress them, potentially triggering the birth of new stars in a distant future. Thus, even as one star dies, it may catalyze the creation of many others, a cosmic circle of life and death. It's a beautiful thought. From the ashes of a star, new suns and new worlds will eventually spring forth. For weeks, this supernova remains ferociously bright. If such an explosion happened in a nearby part of our galaxy, it would be a spectacle visible even from Earth's night sky. In fact, human astronomers have witnessed a few such events in history. In the year 1054, observers in China and elsewhere recorded a guest star that shone brightly even in daylight for weeks. We now know this was a supernova in the Milky Way. The beautiful Crab Nebula we see through telescopes today is the remnant of that very explosion, still expanding nearly 1,000 years later. These stellar cataclysms are rare. In a galaxy of hundreds of billions of stars, a supernova might occur only once in a century or so, but they have a profound impact. They enrich galaxies with heavy elements and dramatic energy, and occasionally they catch the attention of any creatures who might be watching the skies. Gradually, over months and years, the supernova's initial glare begins to fade. The furious glow settles into a persistent afterglow. Perhaps after a year or two, to a distant observer, the supernova no longer outshines the entire galaxy, but its expanding cloud is still visible as a faint nebula at the site where the star once was. Long after, centuries and millennia later, the remnants will continue expanding and cooling, becoming a veiled mist of gas, studded with the heavy elements that were created. In the center of this magnificent expansion lies something remarkable. Where once the core of the star resided, there is now a new object, born of the collapse. The core's material has been so intensely compressed that it has formed a neutron star, an ultra-dense stellar remnant. This neutron star is like a cosmic ember left from the fire, incredibly hot and dense. If the star had been even more massive, the core might have become a black hole instead, swallowing even light itself. But in our case, we detect the presence of a neutron star, a tiny, dense sphere only about 10 miles across, hidden in the glare of the receding explosion. As the supernova's brilliance ebbs, our attention turns to this small, strange leftover at the heart of the chaos. The space around it is still aglow with expanding debris, but that debris is thinning, and emerging from it is the faint but steady beat of energy from the newborn neutron star. The cataclysmic chapter of the supernova is closing now, the star's death flash fading into memory, and a new chapter is beginning, focusing on the exotic object that remains. In the quiet aftermath of the blast, we approach that stellar remnant, eager to understand what kind of beacon the old star's core has become. In the aftermath of the supernova, we draw closer to the small but extraordinary object left behind. Emerging from the thinning haze of glowing debris is a neutron star, the collapsed core of the once mighty star. At first glance, it might not look like much, just a tiny, fiercely luminous point, no larger than a city. But within that sphere is the mass of our sun, or more, compressed into an incredibly small volume. The neutron star's gravity is intense, beyond comprehension. It bends the very fabric of space around it. If we were to hover near this object, we would find that light itself curves around it. The gravity is so strong that you could see the backside of the neutron star slightly from the front, as light from the far side is pulled around by the star's gravitational field. We are beholding one of the densest forms of matter in the universe. The numbers associated with a neutron star defy imagination. If we could somehow take a teaspoon of its material, an impossible feat, that tiny amount would weigh billions of tons under Earth's gravity. It's as if an entire mountain were squeezed into a thimble. The neutron star is only about 20 kilometers, 12 miles, across, yet contains the mass of a sun. Its surface gravity is so high that anything standing on it would be instantly crushed flat, and the escape velocity is a significant fraction of the speed of light. This is truly a stellar extremity, matter pushed to the ultimate limit. The neutron star spins rapidly. When the giant star exploded, its core, like a spinning ice skater pulling in her arms, whirled faster as it shrank. What was once perhaps a leisurely rotation in the old star's core has become a dizzying spin. Our neutron star might be rotating dozens of times each second, an unthinkable speed for something of its size and mass. Some neutron stars spin even faster, hundreds of rotations per second. These are called millisecond pulsars, while others rotate more slowly, especially as they age. Surrounding the neutron star is an immensely strong magnetic field, far stronger than the sun's field ever was. As the star spins, this magnetic field and the trapped charged particles around the star produce beams of electromagnetic radiation that stream out from the star's magnetic poles. In effect, the neutron star has become a cosmic lighthouse, sweeping space with beams of energy. We position ourselves so that one of the star's polar beams periodically sweeps over our location. Now we witness an incredible sight. With each rotation of the star, a brilliant pulse of light flashes past us. Flash, flash, flash. A steady rhythm in the darkness. We have encountered a pulsar, a rotating neutron star, whose lighthouse-like beams are pointed in such a way that they flash toward us with every spin. To our eyes, it appears as if the star itself is blinking on and off with a precise regularity. In reality, that beam of radiation, often radio waves, but sometimes also visible light or X-rays, is sweeping by like the beam of a lighthouse as the star spins on its axis. The pulses are astonishingly regular. If this neutron star spins, say, 30 times a second, we observe 30 flashes each second, like clockwork. Pulsars are some of the most reliable timekeepers in the universe. Their pulses arrive so predictably that we could set a clock by them. It is as though we are listening to the heartbeat of a dead star, a rhythmic, unyielding beat echoing across space. In fact, pulsars were so regular and precise when first discovered that astronomers half-jokingly wondered if they might be signals from an intelligent civilization. The first pulsar ever detected was nicknamed LGM-1 for Little Green Men 1, as a tongue-in-cheek nod to that speculation. Soon, however, it became clear these signals were natural, the beams of a spinning neutron star. We marvel at the nature of this object. Not long ago, it was the core of a living star, where nuclear fusion raged and supported the star's weight. Now it is a stellar corpse, yet it has a form of afterlife. In death, the star has become a beacon, its rapid spins and strong magnetic fields broadcasting a cosmic announcement of the star's demise. The chaos of the supernova has transformed into the calm, methodical flashing of a pulsar. It's a poignant transformation, a brilliant explosion giving birth to something as orderly and regular as a ticking clock. Imagine being in a spacecraft orbiting such a neutron star at a safe distance. The sky around you would be flooded by the faint glow of the expanding supernova remnant, but one point at the center would be strobing steadily. Every few milliseconds or seconds, depending on the pulsar's rate, a sweep of invisible radio energy and possibly a brief flash of visible light would wash over your ship. You'd have an otherworldly lighthouse keeping you company in the cosmic night. Each pulse a reminder of the star that once was. Indeed, scientists on Earth use pulsars as precise cosmic clocks and even as navigation beacons for spacecraft. So stable are their rhythms. Over tens of thousands of years, the pulsar will gradually slow down, its flashes growing slightly farther apart as it loses energy. Eventually, after millions of years, it may spin down so much that it no longer emits noticeable pulses, becoming a quieter, inert neutron star that simply cools in the dark. But that is far in the future. Right now, this neutron star continues its beacon-like performance With unwavering consistency, as we float in the presence of this spinning marvel, we feel a sense of reverence. This tiny, dense object is the surviving heart of a star that once dominated its corner of space. It is a stellar remnant, a monument to the extremes of physics. In its intense gravity, rapid spin, and ghostly beams, it challenges our understanding of nature's limits. Gazing at this pulsar, we can't help but wonder about an even more extreme possibility. If the original star had been even more massive, the core collapse wouldn't have stopped here at a neutron star. The core would have continued to collapse until it formed a black hole, an object even more mysterious, where gravity reigns without limit and not even light can escape. With that thought, we prepare to take another bold step on our cosmic journey. We leave behind the gently blinking neutron star, this marvelous lighthouse of the dark, and set our sights on the ultimate abyss, the realm of black holes, where the fabric of space and time itself is stretched to its limits. We depart the vicinity of the pulsar and seek out a place where the boundary between existence and nothingness is laid bare. In a quiet corner of the galaxy, we come upon an object even more enigmatic than a neutron star. Here, a massive star's core did not settle for a neutron star when it died. It continued to collapse until it created a black hole. At first, we do not see anything at all. A black hole, by its very nature, emits no light of its own. It is a region of space where gravity has overwhelmed all other forces. The star's entire remaining mass has been crushed into an infinitely small point, and around that point is a sphere of influence, the event horizon, marking the boundary beyond which nothing can escape, not even light. This invisible boundary is the point of no return. We know the black hole is there because of its effects on the environment. In this region, we notice a swirl of hot, glowing gas orbiting seemingly empty space. In fact, a companion star is nearby, and the black hole's gravity is pulling gas away from it, devouring the material. That gas forms an accretion disk, a broad, flat spiral of superheated matter whirling around the black hole. Friction and compression heat the gas to extreme temperatures, so it shines in X-rays and a faint blue-white light. To our eyes, we see a ghostly disk of light, seemingly orbiting nothing. As the gas spirals inward, it moves faster and gets hotter, glowing brighter until, just before it vanishes past the event horizon, it emits a burst of high-energy radiation. This deadly, beautiful whirlpool of light is the black hole's footprint on the observable universe. Just above the poles of the black hole, we see a different phenomenon. Narrow, powerful jets of particles being shot out into space. Not all the infalling material ends up beyond the horizon. Some of it, due to magnetic forces in the disk, gets redirected outward along the black hole's rotational poles. These jets stream out at nearly the speed of light, carving through interstellar space. They are like cosmic searchlights, announcing the presence of the feasting black hole. The jets themselves glow with energy. We can trace them stretching far beyond the accretion disk, fading into the darkness. In the giant elliptical galaxy M87, astronomers have observed such a jet shooting out from its central black hole, extending tens of thousands of light years into space, a cosmic beacon visible across intergalactic distances. As we carefully drift closer, we become acutely aware of the distortions of space around the black hole. The gravity here is so strong that it warps the path of light significantly. We look toward the background stars and notice they appear oddly shifted and smeared into arcs. In fact, the black hole is acting like a lens, bending the light of objects behind it into rings and halos. If we align just right, the light of a distant galaxy directly behind the black hole is bent into a perfect circle around the black hole's silhouette, an Einstein ring of concentrated light. It is an eerie sight, a circle of light where that distant galaxy's image has been wrapped around a bottomless dark center. Approaching the black hole's event horizon, in thought, if not in person, leads us into some of the greatest mysteries of physics. If an object, say a spaceship or an unlucky astronaut, were to get too close and start falling in, several bizarre things would happen. To an outside observer, like us, watching from afar, that ship would appear to slow down as it neared the event horizon. Time itself runs differently in the strong gravity near the black hole. The ship's fall would seem to stretch out. It would get dimmer and redder, and it would never be seen to actually pass through the horizon. It would just fade away at the edge, frozen in time from our perspective. But from the ship's own viewpoint, nothing particularly dramatic might be noticed at the horizon itself. It would pass the invisible boundary without fanfare, and in a very short time, it would reach the vicinity of the black hole's center. The fate of anything that falls inside is sealed. Closer to the center, the forces of gravity grow so horribly strong that they create immense tides. The pull on the front of the object is much stronger than on the back, stretching it out violently. In whimsically morbid terms, scientists call this process spaghettification, because anything, even a person, would be stretched into a long, thin shape like a piece of spaghetti by the tidal forces near the black hole. Ultimately, all matter that falls in will be crushed at the central point, the singularity, a place of almost infinite density where the normal rules of physics break down. It's a realm we do not truly understand. Our laws of nature can't describe the conditions there. It's possible that at this singularity, space and time themselves come to an end. Some have speculated that the matter might re-emerge elsewhere, or that black holes could even be gateways to other universes via hypothetical wormholes. But these ideas remain in the domain of theory and speculation. For now, the interior of a black hole remains one of the universe's darkest mysteries. Given these extreme conditions, one might expect black holes to be cosmic terrors, devouring everything. But in truth, if a black hole is left alone with nothing to consume, it is surprisingly undramatic, essentially impossible to detect, and quietly persistent. A lone black hole roaming interstellar space would be effectively invisible, perceived only by its gravitational tug on nearby stars or its lensing effect on background light. Black holes do not go around sucking in everything in the universe. An object has to come quite close to fall in. In fact, if our sun were suddenly replaced by an equal mass black hole, purely hypothetically, the planets would continue to orbit almost unchanged. They would feel the same gravitational pull, though of course we would lose sunlight and all life-supporting radiation. Black holes can also slowly evaporate over extraordinarily long times through a process predicted by quantum physics, known as Hawking radiation. They emit tiny amounts of particle-antiparticle radiation at their event horizons, causing them to lose mass ever so slowly. But this is an almost imperceptible trickle for large black holes. A stellar mass black hole would take far, far longer than the current age of the universe to evaporate completely. Still, it's a profound thought. Even these dark giants aren't truly eternal. Not all black holes are formed equal. While some are the remnants of single stars, with masses a few times that of the Sun, there are monsters in the centers of galaxies that reach millions or billions of solar masses. These are supermassive black holes, and they anchor the hearts of galaxies. Our own Milky Way has a supermassive black hole at its core, calm and quiet at the moment. We know it's there because we observe stars near the galactic center, whipping around an unseen mass. These stars move at incredible speeds in tight orbits, as if tugged by an invisible hand. From tracking their motions over years, astronomers have deduced that they are orbiting a dark object about 4 million times the mass of our Sun, confined in a space smaller than our solar system. Only a black hole could be so massive, and yet so compact. We call this object Sagittarius A, and it lies about 26,000 light years from Earth, hidden behind clouds of dust and gas. In 2022, scientists using a network of radio telescopes, the Event Horizon Telescope, managed to capture an image of this black hole's immediate surroundings. They revealed a glowing ring of light, hot gas swirling around, and a dark central shadow where the black hole resides. Earlier, in 2019, the first ever direct image of a black hole in galaxy M87 was released, similarly showing a bright ring around a dark shadow. These observations confirm that the mysteries we speak of are not merely theoretical. We can actually see the imprint of a black hole's event horizon. We are essentially looking at the silhouette of the event horizon itself. It was a monumental confirmation that these objects we imagined in equations are very real. Even more massive black holes power quasars, the brilliant beacons seen across the universe in the hearts of young galaxies. When a supermassive black hole consumes large amounts of gas, the accretion disk and jets can become so luminous that they outshine the entire galaxy. Quasars are among the brightest objects in existence, visible from billions of light years away. In the distant past, when galaxies were young and gas was abundant, many galactic centers blazed as active quasars. Now, quasars are rarer. Many supermassive black holes have consumed their fill and gone quiescent, like a once raging fire now down to embers. Black holes can also announce themselves through a different messenger: gravitational waves. When two black holes spiral together and merge, they produce ripples in the very fabric of space-time. Much like a stone dropped in a pond creates ripples in the water, these gravitational waves spread out across the cosmos. In recent years, scientists on Earth have detected these waves with special observatories. They've heard the subtle tremor of space-time from black holes colliding billions of light years away, a faint rising chirp in the detectors that lasted only a fraction of a second, yet spoke volumes about massive objects merging in darkness. This was yet another confirmation that black holes are not just theoretical. We can observe their effects even when they merge in complete darkness, through the vibrations of the universe itself. Contemplating a black hole, we confront some of the deepest questions about nature. These objects represent a limit, where our understanding breaks down, and where the universe challenges us to extend our knowledge. They are at once fearsome and fascinating, and despite their reputation as destroyers, black holes play a role in the cosmos, sculpting galaxies, regulating star formation with their energetic outbursts, and contributing to the cosmic cycle by eventually returning energy via Hawking radiation back to the universe. As we drift away from the vicinity of this black hole, leaving its warped space and fiery accretion disk behind, we carry with us a sense of awe. We have journeyed from the gentle light of stars through their dramatic deaths to this ultimate darkness. Our exploration of individual stars and their remnants, from calm red dwarfs to blazing supernovae, from pulsating neutron stars to silent black holes, has shown us the life cycle of stars in all its grandeur and mystery. Beyond the realm of these stellar remnants, an even larger stage of cosmic wonder awaits us. The stars we've been visiting are but tiny points within vast galaxies. Each galaxy is an island of hundreds of billions of stars, nebula, and perhaps a supermassive black hole at its core. Our next voyage will carry us out of the stellar neighborhood and into the wide expanse of those galaxies, where we'll see how stars gather in enormous cosmic cities, and how the universe extends far beyond our own Milky Way. But for now, we pause, letting the profound silence of the black hole's domain sink in. In this quiet moment, at the edge of a cosmic abyss, we feel both the immensity of creation and our gentle place within it, ready to continue onward when the time comes. In the stillness of a clear night, a soft, luminous band arches across the sky. It glows gently above, a pale river of light flowing through the darkness. For a moment, time seems to stand still under this shimmering vault of stars. This gauzy glow is the Milky Way, our home galaxy, embracing us from above. It stretches from horizon to horizon, a misty pathway made of countless distant suns. Long ago, before city lights drowned out the heavens, our ancestors would gaze up at this celestial wonder with awe. They saw more than just stars. They saw stories written in the night. To ancient eyes, The Milky Way was a great silver river in the sky, a glowing stream where earth and heaven met. Some imagined it as the dust of a divine road, a pathway for gods travelling across the night. Others called it a river of souls, believing that the spirits of loved ones wandered along its glowing trail to reach the afterlife. On nights like this, it's easy to understand why they felt that way. The Milky Way spills across the darkness like a trail of light, inviting wonder and curiosity. In one old story, it was said to be milk from a goddess, strewn across the heavens to form a protective band of light. In another tale, it was a bridge made of stars, a bridge that only opens once a year to reunite two celestial lovers separated by the river of the sky. All around the world, people looked up and gave this misty band their own names: the Sky River, the Spirit Road, the Path of Birds. Each name was a reflection of how it touched their hearts and imaginations. Beneath this starry arch, we feel both small and at home. We lie on our backs in dewy grass or on warm sands, looking up. The night air is cool and still. Overhead, the Milky Way glistens, its light so faint and delicate, yet made of uncountable stars. In its soft light, one can almost see patterns, wisps and swirls where the stars cluster, and darker gaps where clouds of cosmic dust obscure their glow. Those dark patches were mysteries to early sky watchers. Some saw the shape of a great emu stretching across the heavens, or a llama with her child, figures drawn not in stars, but in the spaces between them. To others, those shadows were the footprints of gods, or the smoke of campfires lit by ancestors in the sky. Slowly, as your eyes adjust to the darkness, more and more stars emerge into view. The longer you gaze, the more the Milky Way reveals its depth. What first seems like a faint cloud of light breaks into countless points, each a star shining across unimaginable distance. There are bright clusters and subtle glows of nebulae within it, places where new stars are born, hidden amid the darkness and light. It's as if the galaxy itself is alive, breathing, with regions of thick, starry dust, where new suns and planets will one day spark into existence. In the heart of the Milky Way, towards the constellation of Sagittarius, lies a hidden realm that our naked eyes cannot pierce. There, millions upon millions of stars crowd together, swirling around an ancient, gentle darkness, a supermassive black hole resting at the galaxy's core. We cannot see this cosmic heart directly, but its presence holds the Milky Way in a quiet, gravitational embrace. Around it, stars orbit slowly over centuries and millennia, like dancers circling a silent center. From our vantage point far out in the galactic suburbs, we see the combined glow of that dense center as a bulge of light, wrapped in a veil of dust. Our sun, with all its planets, is just one tiny star in this vast city of stars. We live in a quiet neighborhood, nestled in one of the spiral arms of the Milky Way. Every star you see on a clear night is part of our galaxy, a fellow resident of this enormous cosmic home. Some are near, shining brightly. Others are far, faint and whispery. Together, they form this luminous band that has guided and comforted humanity for ages. Imagine for a moment riding a beam of light across the galaxy, even moving at the fastest speed in the universe. It would take 100,000 years or more to cross from one end of the Milky Way to the other. Such is the grandeur of our home galaxy, a vast disk of stars, dust, and glowing clouds, rotating slowly like a giant, tranquil pinwheel in space. One rotation takes hundreds of millions of years. In the grand calm of cosmic time, our sun drifts along, carrying Earth and all of us with it, gently orbiting the galactic center as if on a long, circular journey. As we drift in thought through this starry expanse, we pass clusters of stars that sparkle like jewels. We float by wispy nebulae, softly glowing clouds where new stars are cradled. There is the Orion Nebula, a faint patch of hazy light, even visible from Earth on a clear winter night. Inside it, dozens of baby stars are forming in a cosmic nursery. There are ancient globular clusters hanging like lanterns above the plane of the galaxy, each containing hundreds of thousands of old stars tightly bound together, relics from the youth of the Milky Way. All these wonders are part of our galaxy's story. For countless nights in human history, around campfires or lying on quiet hilltops, people have felt the pull of that starry band. They whispered stories to each other about its origin and meaning. Perhaps they pointed out a particularly bright patch and imagined it was the glow of a great celestial city, or that the dark rifts were the outlines of celestial creatures watching over us. Every culture found its own comfort in this sight. In India, they spoke of the heavenly Ganges River flowing in the sky, mirroring the sacred river on earth. In China, they told of the Silver River separating two lovers, a cowherd and a weaver, who could only meet when a bridge of birds formed across the stars. In the Americas, some native peoples called it the Path of Souls, believing that the spirits of the departed travelled that luminous road to the next world. And in Europe, they eventually came to call it the Milky Way, inspired by the ancient Greek tale of milk spilled from the breast of a goddess across the heavens. Though the names and stories differ, the feeling is the same, a mixture of wonder and belonging. Looking up at the Milky Way, one senses both the infinite and the intimate. It is infinite in its expanse and numberless stars, yet intimate in how it has touched human hearts. You can almost feel the echo of those who came long before us, gazing at the very same band of light, drawing comfort and inspiration from its presence. They stood, perhaps, in a different world, one without modern knowledge, but maybe with a deeper, nightly connection to the stars, and they too felt the gentle tug of the galaxy on their imagination. High above, the Milky Way continues to glow, patiently shining as it has for billions of years. The Earth turns slowly, and the band of the Milky Way shifts, rotating overhead in the course of the night. If you stay out long enough, you can watch it arch from one end of the sky to the other, slowly drifting as the hours pass, like a great wheel turning silently. There is no sound out here, just the soft night breeze and the sense of the cosmos overhead. One can feel a profound peace beneath this celestial canopy, as if the universe itself were watching over us. Out in the countryside, away from city lights, the view is so vivid that it almost feels three-dimensional. Stars close and far, bright and dim, all layered in the sky. It's a scene that reminds us of our true home in the cosmos. We live not just on a planet or in a solar system, but within this great galaxy swirling with stars. We orbit one star among billions, tucked safely in a spiral arm that itself drifts through the endless night. In places where the darkness is deepest, the combined light of the Milky Way's stars can even cast a faint, ghostly shadow. Imagine standing on a moonless night and seeing your outline softly traced on the ground by starlight alone. Such is the gentle power of a billion distant suns woven together. It reminds us that even in what seems like pure darkness, there is light all around, quietly illuminating the night. The Milky Way is cozy and grand all at once. Cozy, because it is our neighborhood of stars, the cosmic family to which our sun belongs. Grand, because it spans such immensity and contains such wonders that we will never see them all in a lifetime. When we think of it, perhaps we imagine the pictures taken by telescopes, a giant spiral galaxy with curved arms and a bright core. Yet here on Earth, to our eyes, it is seen, edge on from within, a glowing band, mysterious and diffuse. Both perspectives are true, and both are beautiful. Our knowledge tells us it is a spiral galaxy, rotating through space, carrying stars, planets, and nebula in its sweep. Our imagination, however, sees it as a river of light, a bridge, a pathway in the sky. Tonight, as the Milky Way gazes down, it quietly links us to all times and places. The photons of light hitting our eyes might have left their stars hundreds or even thousands of years ago, crossing space to reach us. When you behold the Milky Way, you are literally seeing ancient light, some of it older than civilization itself. In that way, the galaxy connects us not only across geography, but across time. The light from a star might have started its journey when our distant ancestors were first learning to make fire, and only now finishes its long voyage to meet your eyes. That star might long since have dimmed or died, but its memory, in the form of light, lives on in the band of the Milky Way. Such thoughts gently remind us of the scale of things. Our human lives, our concerns, our stories, they all unfold on a tiny stage within this enormous galaxy. Yet the very atoms in our bodies were forged in stars like those above. We are part of this Milky Way in a very real sense. The iron in your blood, the calcium in your bones, those elements were created in ancient stars that lived and died before the sun was born. The galaxy is our home, not just in space, but in substance. So as we lie here under the starry sky, feeling the cool night air and the solid earth beneath, we also feel a connection upward to the Milky Way. It cradles us from above, like a great starry embrace. Its light is faint, but steadfast, a gentle band that arcs over the sleeping world, reminding us that beyond the immediate darkness lies a grander tapestry. And beyond that tapestry of our own galaxy, farther out in the darkness, there are other lights too, faint and far, scattered deep beyond the Milky Way's edge. As we let our eyes drift toward the horizon, we realize that the Milky Way, for all its vastness, is but one of many. The universe extends far past the borders of our galactic home, into an ocean of other galaxies, shimmering like distant islands of light. Our journey carries us outward, beyond the gentle glow of our own Milky Way. In the far distance ahead, the darkness of space is sprinkled with faint glimmers. Other galaxies, each an enormous gathering of stars like our own, but so distant they appear only as tiny smudges of light. As we drift farther from our galaxy's familiar light, we enter the quiet gulf of intergalactic space. Here, between the galaxies, the night is deeper and more silent than any earthly night. It is a vast ocean of darkness, with galaxies scattered through it like isolated islands, each aglow with the fires of billions of suns. The first islands of light we encounter are the nearest to our Milky Way. In the skies of the southern hemisphere on Earth, 2 pale clouds can be seen on a dark, clear night. Floating near the edge of vision, they look like pieces of the Milky Way that have broken off. These are the Magellanic Clouds, 2 dwarf galaxies, small companions orbiting our own. They quietly accompany the Milky Way, circling around it across eons. If you were to visit one, you would see a miniature galaxy, less orderly than our spiral home, but filled with stars all the same. The large Magellanic Cloud, the bigger of the 2, glows with patches of bright nebulae where new stars are being born. The small Magellanic Cloud, a bit fainter, is like a tiny sprinkling of stardust off to the side. Together, they travel with us, cosmic siblings sharing our journey through space. Moving beyond our immediate neighbours, we set our sights on the great Andromeda Galaxy, the nearest large spiral galaxy to our own. To the unaided eye on an ink-black night, Andromeda is just a faint blur, a little oval of light in the constellation of Andromeda. But through imagination, or a telescope's eye, that blur becomes a majestic spiral of hundreds of billions of stars. As we approach it in our mind's eye, Andromeda unfurls before us like a grand pinwheel. Its spiral arms sweep gracefully outward from a bright, glowing core. The arms are lined with blue clusters of young stars and accented by pinkish clouds of glowing gas. Vast nurseries where stars are being born. The core of Andromeda is older and golden, filled with ancient stars crowded around a central black hole, similar to the one in our own galaxy's heart. Andromeda and the Milky Way are a pair bound by fate. Across the silent gulf of space, they are drifting toward each other, drawn by their mutual gravity. But there is no need for alarm. The dance of galaxies is exceedingly slow. It will be billions of years before they eventually meet. When they do, it won't be a violent crash as one might imagine. Rather, they will begin to swirl together, their stars mingling and passing by one another like grains of sand in a gentle tide. Over a long span of time, the two will merge into a new, larger galaxy, their spirals dissolving into a different shape. For now, however, they remain separate, each a tranquil spiral drifting through the cosmic night. We can appreciate the serenity of Andromeda as it is now, quietly shining, a giant city of stars hovering in the darkness. As we float onward, leaving Andromeda behind, the universe reveals more of its distant architecture. Galaxies of all shapes and sizes appear in the vastness. Some are elegant spirals, like our Milky Way and Andromeda, their arms winding outward in delicate swirls. Others are gigantic ellipses, oval-shaped galaxies that contain trillions of stars, but little gas or new star formation. These elliptical galaxies glow softly with the collective light of countless older stars, giving them a gentle, golden hue. They are like cosmic retirement homes, where ancient stars live out their long, peaceful lives, and few new stars are born. Then there are peculiar galaxies of various forms. Some are irregular, with no definite shape, perhaps moulded by past encounters or collisions. They look like scattered clouds of stars. Others have rings, or strange twisted tails of light flung out into space. These odd shapes tell stories of past interactions. Maybe two galaxies passed close by each other, and their gravity wove a tidal bridge between them, pulling out streams of stars and gas like taffy. Even these cosmic interactions happen in slow motion by our standards, over many millions of years. From our perspective, in a single human lifetime, or even in the span of human history, galaxies seem frozen in their graceful forms, like eternal works of art lighting the darkness. Occasionally, as we survey the cosmos, we come across clusters of galaxies, entire communities of these star cities gathered together. In a galaxy cluster, dozens or even hundreds of galaxies are bound in a gigantic group, swarming around a common center. If we could stand on a world in a galaxy at the heart of one of these clusters and look up at the sky, we would see many galaxies shining in the darkness, some large and bright, others small and faint, scattered across the heavens like a celestial cityscape. Imagine a night sky where not just stars, but whole galaxies are visible as tiny patches of light. That is the reality in the densest clusters, though no human eyes have seen it directly. It is the realm of telescopes and imagination. One famous cluster lies in the direction of the Virgo constellation as seen from Earth. Fittingly called the Virgo cluster, it is the heart of our larger galactic neighborhood. Here, the giant elliptical galaxy Virgo A, also known as M87, reigns among many companions. M87 is a massive, rounded galaxy, a great ball of stars with a softly glowing halo. Deep in its core lurks one of the most massive black holes known, which occasionally sends out jets of energy far into space. Yet from afar, M87 appears serene, a gentle hazy orb of light among its neighbours. The cluster around it is full of variety. Spirals, ellipticals, and irregulars all float in a tenuous dance, bound together by gravity. Beyond the Virgo cluster, we venture further into the depths of space. The farther we go, the fainter and more numerous the galaxies become. With each step outward, new galaxies come into view, like stepping back in a forest to see more trees. There are billions of galaxies in the observable universe, scattered across the cosmic landscape. In every direction, if we peer far enough, the darkness gives way to the soft glow of distant galaxies. We might imagine ourselves in a quiet cosmic field, where each wildflower in the distance is a galaxy, and they stretch on and on, farther than the eye can see. At such immense distances, even entire galaxies appear as mere pinpricks or faint swirls of light. To truly sense them, we rely on our finest instruments, or the power of imagination. Telescopes like Hubble have stared for days into seemingly empty patches of sky, only to reveal that they are filled with galaxies upon galaxies, each a tiny beacon in the void. In those deep field images, every speck of light is a galaxy, some so far away that their light has travelled for billions of years to reach us. We are essentially looking back in time, seeing those galaxies as they were eons ago, when their light first began its journey. Think of that for a moment. The universe is so vast that the light from some galaxies set out when our Earth was young, and only now is arriving. In that time, entire species have arisen and vanished on our planet. Civilizations have been born and fallen, and all the while, the silent light crossed the emptiness, unwavering, to bring us a picture of the past. It is humbling, and yet strangely comforting, that the cosmos preserves its history in this way, encoded in the travelling light. As we gaze upon these myriad galaxies, we might wonder about the worlds they contain. Each galaxy holds countless stars, and around many of those stars may circle planets. On some of those worlds, perhaps life has found a foothold, and maybe even intelligence and curiosity. Could there be other beings under some alien sky who look out and see our Milky Way as just another faint smudge and wonder what it is? The cosmos inspires such questions softly in our minds. We feel a kinship with whatever might exist out there, not because we know of them, but because we share the same universe, the same broad night. The diversity of galaxies is breathtaking. Some, like the Whirlpool Galaxy, present a face-on spiral display, with arms gracefully curling and a smaller companion galaxy tugging at one of its arms. Others, like the Sombrero Galaxy, are seen edge-on from our vantage, appearing as a thin disk with a bright core and a halo of light. It looks like a cosmic hat adorning the darkness. There are also faint dwarf galaxies, barely held together, flitting around larger galaxies like moths around a flame. And there are the extremely distant ones, only discovered in sensitive photographs, ghosts of light on the threshold of nothingness. In all this variety, there is also an underlying harmony. Galaxies often gather into patterns on a grand scale, forming filaments and walls across the universe. These arrangements span hundreds of millions of light years, like the design of a colossal cosmic web. Yet even this immense cosmic web, with its filaments of galaxy clusters and its vast voids, has a quiet elegance. If we pull back our view even more, the tapestry of the universe emerges, a delicate lattice of matter, with galaxies glimmering along invisible threads of gravity, surrounding huge dark spaces where few galaxies roam. It is both beautiful and mysterious, a structure so vast our minds can scarcely grasp it, yet so simple in its form, much like a gentle lacework of lights in the night. Floating here, between these distant galaxies, we find a deep peace in the solitude. The space around us is almost perfectly empty, a vacuum with only the occasional stray atom or wandering photon. Far from any star's glow, the darkness is nearly absolute. Yet, no matter how empty it seems, there is always the faint glow of a galaxy somewhere in the distance, if you look long and carefully enough. The universe ensures that even in the deepest void, there is some light to be found, however faint. We drift onward, allowing the enormity of it all to wash over us. We have seen galaxies near and far, from our gentle Milky Way and its neighbours to the farthest reaches of the observable cosmos. Each one is a marvel, a testament to the grandeur of creation. In their light, we find beauty. In their darkness, we find mystery. And through it all, a sense of calm pervades, because even at the largest scales, the universe moves in slow, graceful ways. Stars orbit galactic centers quietly. Galaxies themselves drift and dance over eons. It is a cosmic slow dance, almost imperceptible in any given moment, yet unfolding in majestic form over the ages. As we contemplate these island universes, we may feel that our earlier myths and stories, our first attempts at understanding the sky, are not so distant from this reality after all. We gave the Milky Way names, like the Sky River or the Path of Souls, without knowing it was made of stars. Now we know it is one galaxy among many, and we see actual galaxies scattered like islands in a cosmic sea. The ancient idea of islands in the sky was more true than those dreamers could have realized. Each island universe out here is a world unto itself, full of possibilities, just as our own is. With that thought, a gentle wonder stirs in our hearts. We have journeyed out among the galaxies and found not emptiness, but a universe teeming with light and variety. And yet, no matter how far we go, there is always beyond. We could continue this voyage without end, for the universe is vast and perhaps boundless. But for now, we will pause in our outward journey. It is time to reflect on how all of this came to be, not in terms of science alone, but also through the rich tapestry of human imagination and myth that has tried to explain our cosmic origins. Since the dawn of humanity, we have sought to understand how all of this came to be. Long before scientific theories, we crafted beautiful stories to explain the birth of the cosmos. These creation myths, born in every corner of the world, are like gentle dreams about our beginnings. As we drift now in the darkness between the stars, let us recall some of those ancient stories, letting them flow softly through our minds like a comforting bedtime tale. In one tale, told along the banks of the Nile, in the land of ancient Egypt, the universe began in darkness and endless waters. Nothing stirred in that primordial sea until a beautiful lotus flower rose above the dark surface. When the lotus bloomed, its petals revealed a shining infant, the newborn sun god. His light spread out, bringing the first dawn to the cosmos. From that first light, the story goes, all other things came into being. The sky and the earth were formed. Gods and goddesses took their roles, and the world as known to the Egyptians unfolded from the touch of that initial sunrise. Far to the east, another story speaks of a cosmic egg floating in the void before time began. In the vast emptiness, this egg contained the potential of everything. For ages, it remained unbroken, until finally it hatched. From the golden cosmic egg emerged the Creator and all the ingredients of the universe. The shell of the egg became the arching sky, its broken pieces glinting and becoming the stars. The yolk formed the fertile earth and the waters. And the first sound that echoed was Om, the sacred resonance of creation itself. In this Hindu imagining, the universe was born as gently and naturally as a chick from an egg. Life emerging from a solitary seed of existence into a glorious diversity. On a distant group of islands in the Great Pacific, the Maori people tell of Rangi and Papa, the Sky Father and the Earth Mother. In the beginning, Rangi and Papa were locked in a loving embrace so tight that no light could pierce the darkness between them. Their children lived in this perpetual night, cradled between sky and earth, until they yearned for space and light. The children decided to push their parents apart. With great effort, they pried sky and earth from each other's grasp. At last, a sliver of light dawned in between. It grew and spread, becoming the first daylight and revealing the world for the very first time. The Sky Father was lifted high above, arching over the world, and the Earth Mother lay below, giving birth to forests, oceans, and living creatures now that light had come. Though separated, the love of Rangi and Papa endures. The soft rain that falls from the sky are said to be Rangi's tears for his beloved earth, and the morning mist that rises from the ground is Papa's sighs for the sky. In the lore of ancient Greece, at the very start, there was only chaos. Not chaos as in disorder, but chaos as a yawning gap, an endless, empty void. From that void, mysteriously, came the first primordial beings, Gaia, the earth, emerged, providing a foundation. Then came Uranus, the sky, who stretched out above the earth and became studded with countless shining stars. Together, earth and sky bore many children, among them the sun, the moon, and the dawn, thus filling the once empty cosmos with form and life. To the Greeks, the world was born out of emptiness by the union of earth and sky, making the universe a kind of family of divine beings. Travelling north to colder lands, we find the Norse tale of creation. They tell of a great, gaping abyss called Ginnungagap, flanked on one side by a realm of icy mist and on the other by a realm of fire. In the middle of the gap, the heat met the cold, and the ice began to melt, drop by drop. From those drops of water, life slowly took shape. First the giant Ymir, and a cow to nourish him. As Ymir slept, from his body came the first humans and more giants. In time, the gods, born later, crafted the world from Ymir's body. They lifted up his skull to make the sky, placing sparks of fire as the stars. His flesh became the earth, his blood the sea, and his breath the wind. Though this tale has grim details, the Norse told it on long winter nights by the fire, illustrating how even from ice and fire, darkness and heat, a world can emerge and take shape. Another ancient story, shared in the Near East, begins in a deep, silent darkness. There was nothing but a formless void and the waters of an abyss. Then a divine voice uttered a single command: "Let there be light." And there was light. Suddenly, in the void, light appeared, separating itself from darkness. With light came the beginning of time and order. Over the following days of this creation story, the voice called into being the sky to divide the waters, the dry land to emerge from the sea, the sun, moon, and stars to grace the heavens, and all living creatures to populate the land and oceans. Finally, human beings were formed in the image of the divine, and on the seventh day, the Creator rested, and the cosmos was complete. This is the story from the Hebrew and Christian tradition, passed down through millennia, offering a simple yet profound answer to how our world came to be, through the word and will of a creator, bringing light and life where there was none. In our modern quest for knowledge, we have uncovered our own cosmic origin story, the scientific narrative of the Big Bang. It tells us that the universe began in a single moment of creation, an immense burst of light and energy from which time and space flowed outward. As the young universe expanded and cooled, the first particles of matter formed, and eventually the first stars ignited, casting new light into the darkness. Galaxies coalesced over billions of years, and among the stars of one galaxy, our sun and earth took shape. Even in this scientific story, one hears echoes of the old myths, a profound beginning out of darkness, and a kind of cosmic dawn when the first starlight appeared. Science gives us equations and evidence, yet the sense of wonder remains the same. We still marvel that once there was nothing we would recognize, and then, in an instant, there was a universe filled with possibilities. Perhaps one day, far in the future, our descendants will tell the story of the Big Bang with the same reverence and poetry that we now give to the tales of lotus flowers and cosmic eggs, as yet another tale of how everything began. From culture to culture, the tales of creation are richly varied. In some, the world emerges from a flower, an egg, or a word in the darkness. In others, it is crafted by gods from the body of a giant, or out of the chaos of primordial matter. Yet beneath these differences lies a shared sense of wonder, a recognition that the existence of the world, of the sun and stars, of life itself, is a profound mystery. These stories were our first lullabies about the universe, told around flickering fires or beneath open skies. They comforted and inspired, assuring listeners that there was an order and a meaning to it all, that the cosmos had a beginning as intimate as a birth, or as intentional as a spoken word. Imagine those ancient nights for a moment. A family huddled under the stars, eyes wide as an elder or storyteller speaks in hushed, rhythmic tones. The night is vast and dark above, spangled with stars, and the Milky Way glows like a ribbon of milk across the heavens. Perhaps the fire is crackling softly, painting flickers of orange light on listening faces. In the distance, a wolf might howl or an owl might call, but around the fire there is only attentive silence. The storyteller weaves the tale of how the world started from a single spark, or how the first dawn chased away endless night. As the listeners hear these words, the darkness feels a little less empty. The cold night becomes a womb of stories, carrying them safely until morning. In the comfort of the story, some eyes grow heavy. A child leans against a parent, drifting to sleep as the tale of creation soothes them. The stars above seem to twinkle in agreement, as if they too are listening and remembering. Not all creation tales involve grand gods or cosmic eggs. Some are simpler and closer to home. There were those who imagined the world was sung into existence by a lonely creator humming a tune in the void, each note bringing forth a star or a mountain. Others pictured that in the beginning, the world was born from love, from a single, heartbroken deity whose tears became the oceans and whose laughter became the sun. Some told of a great spider who wove the universe like a web, strand by strand, connecting everything together. And there are stories of a clever raven who noticed that the world was too dark, and so he stole the stars and the moon from a celestial hiding place. As he flew across the sky, he released them from his beak, and they scattered into the heavens, bringing light and hope to the night. Each culture's imagination coloured creation with the hues of its own land and life. desert peoples dreamed of creation as an emergence from infinite sand and wind. Seafaring peoples envisioned a cosmic ocean giving birth to land. Forest dwellers imagined a great tree or vine that sprouted the world into being. Even relatively recent storytellers, poets and thinkers of the last few centuries, have added to this rich tapestry. They speak of star stuff, the poetic idea that we are made of the same matter as the stars, which science tells us is literally true. But long before we knew that, perhaps we sensed it in our myths when we said we came from the sky, or that our ancestors became stars. Some indigenous stories say that humans fell from the sky, or came down from a starry realm to inhabit the earth. It's a theme echoed by modern science's revelation that the elements in our bodies were forged in stars. In a sense, the old myths and modern science converge. We are children of the cosmos, born of celestial flame and cosmic dust, whether by the breath of a creator or the blast of a supernova. All these myths, old and new, grand or humble, carry a gentle reassurance that the world has an origin and a story, that we belong in it, and that the vast unknown has meaning and pattern. Listening to them, we feel connected not only to the universe, but to all the people who have ever gazed up and wondered. Each story is like a different flower blooming from the same deep soil of curiosity and awe. As we float here and now in our journey, suspended between stars and galaxies, these creation stories remind us of the power of imagination. The universe as science describes it is vast and complex, but through myth and story, we bring it closer to our hearts. We give it familiar shapes: a flower, an egg, a father and mother, a voice in the dark, so that we can cradle the mystery in our minds. In doing so, we realize that the sense of wonder we feel tonight is something humans have felt for tens of thousands of nights before us. The details of the myths may not align with each other or with modern knowledge, but that's not what matters in this peaceful moment. What matters is the feeling they convey, that existence is a wondrous gift, that light emerged from darkness, that we are part of a grand story. That is the shared human wonder in every creation myth, a gentle comfort that somehow the universe and we within it came from something purposeful or beautiful. Now, carrying that comfort and wonder, we turn our attention back to the silent night sky above. We have listened to the old stories of how everything began. They echo softly in our minds, like the fading notes of a lullaby. In this calm reflection, we also remember that even with all our knowledge today, there are still mysteries that elude us. Unseen mysteries that call out to our curiosity and invite us to ponder. We live in an age where science has illuminated so many of nature's secrets. Yet even now, the universe holds its mysteries close. As we peer into the cosmos with our instruments and our minds, we've discovered that much of what exists is invisible to us. There is a profound stillness in acknowledging these unseen things. We call them dark, not because they are evil or frightening, but simply because they do not emit any light we can detect. They are the unseen mysteries that gently influence the universe's story from the shadows. Consider, for a moment, the galaxies we drifted among. They are aglow with billions of stars, yet all that starlight is only a small fraction of what makes up a galaxy. Astronomers found that something else, something unseen, is there too. Something with mass that holds the galaxies together with its gravity. Without this hidden mass, the stars in the outer parts of galaxies would fly off into space, unable to remain bound at the speeds they orbit. It's as if each galaxy is wrapped in an invisible cocoon, encircled by a great transparent halo of matter. This unknown substance is what we call dark matter. We cannot see it or touch it directly. It doesn't shine or reflect light, but its presence is felt in the way galaxies spin and in how the path of light itself bends slightly as it passes through an invisible halo. Dark matter is like a silent partner to the stars, an invisible cosmic glue holding the shining parts of a galaxy together, keeping them gently bound in their celestial dance. We don't yet know exactly what dark matter is. We have some ideas. Perhaps it's made of exotic particles that rarely interact with normal matter, or something stranger still. But for now, it remains elusive. In a way, not knowing adds to the magic of it. It means that even in a cosmos filled with the brilliance of stars, there are still secrets in the dark waiting to be understood. Picture it. All around us, wherever there are galaxies, there are these vast halos of dark matter, like quiet guardians we cannot see. We move through one such halo here in the Milky Way, utterly unaware of it in our daily lives. It doesn't harm us or interact with us in any obvious way. It simply is, providing a kind of unseen scaffolding upon which the galaxies are built and held together. If dark matter were the only mystery, that would be remarkable enough. But the cosmos holds another, even more baffling secret. When scientists looked at how the universe is expanding, they expected to find that gravity might be slowing the expansion over time, as if the universe would gradually ease its outward growth. Instead, they found the opposite. The expansion is speeding up. It's as though there's something out there in the fabric of space itself that's pushing galaxies apart, a sort of gentle cosmic wind or pressure that permeates all of existence. We've given this puzzling phenomenon a name: dark energy. Like dark matter, the word dark simply means we do not yet understand it. Dark energy is even more elusive. We can't see it or feel it directly, but we infer its existence from the way the universe behaves on the largest scales. Imagine the universe as a vast, silent balloon. For a long time, we thought its expansion might be slowing, as if one day it might stop inflating and perhaps begin to contract. Instead, we discovered some unseen influence causing the balloon to inflate faster and faster as time goes on. Dark energy is the name we use for that mysterious influence. We don't know what dark energy actually is. Perhaps a property of empty space itself, a constant energy woven into the fabric of the vacuum, or maybe a field or essence that fills the cosmos. Whatever it is, It means the universe still has surprises for us. Far from becoming static or collapsing, space itself continues to expand, carrying galaxies with it like driftwood on an ever-stretching sea. These concepts can sound daunting, but here in the quiet of our journey, we can think of them more poetically. Dark matter, an invisible presence holding things together. Dark energy, an invisible push spreading things apart. They are like two subtle forces balancing a great story. One gathers and supports, the other gently urges growth and change. In the balanced tension of these two, the cosmos evolves. Over billions of years, dark matter's gravity pulled atoms together into galaxies and stars, while dark energy now causes the vast gaps between galaxy clusters to widen further. The result is the universe we see today, with galaxies clumped in places and great stretches of space between, a tapestry of light and dark, shaped by these counterpoint forces. Knowing about dark matter and dark energy reminds us that reality is not just what we see. There is far more than meets the eye. This realization brings a kind of humble peace. We sit under the stars and realize that even those shining points, as many as they are only a small glimpse of what truly is out there. The universe keeps much hidden, and that is all right. It gives us room to wonder and to imagine. In the old days, what people couldn't see or explain, they filled with myth and story as we remembered. Now, what we can't yet see or explain, we fill with careful experiments and new questions. But in both cases, the unknown inspires our minds. Beyond dark matter and dark energy, there are other cosmic mysteries that quietly linger. Think of black holes. We have learned much about them, yet they remain deeply mysterious. A black hole is a place where matter is so dense and gravity so strong that not even light can escape it. We've managed to capture an image of a black hole's shadow, seen as a dark circle surrounded by a ring of glowing gas. But what lies inside that shadow? We cannot know for sure. The laws of physics, as we understand them, break down in the heart of a black hole, the singularity. It is a cosmic mystery, tucked behind an event horizon, a one-way door in space beyond which we cannot see or return. And yet, black holes themselves are part of the natural life cycle of stars and galaxies. They are like cosmic quiet points. Matter goes in, energy sometimes streams out in jets, but the central secret remains hidden. In our imagination, we might wander near one, seeing stars swirl into a brilliant disk around that darkness and feeling the pull of the unknown at its core. Instead of fear, we can choose to feel curiosity and respect for these powerful, strange objects, acknowledging there are places even our dreams can barely touch. Consider also the question of the universe's beginning, that moment of the Big Bang we mentioned. Science gives us a scenario. But what caused it? What came before it, if anything? We find ourselves at the edge of knowledge, peering over into an abyss of speculation and wonder. Perhaps our universe is one of many, like a bubble in a vast cosmic foam. Perhaps new universes are born from the death of old ones, in an endless cycle. Or maybe time and space themselves began with that first moment, making any before beyond comprehension. These are questions science has not answered, and may never answer with certainty. They remain, like the faintest stars at the far edge of the sky, beckoning, but currently out of reach. Equally mysterious is the distant future of the cosmos. Will the expansion, driven by dark energy, continue forever, with galaxies drifting ever farther apart until the stars within them age and wink out, leaving an endless, quiet darkness? Or might gravity somehow halt the expansion eons from now, perhaps even reversing it, drawing everything back to a single point to begin anew? We do not know the final destiny of the stars. It's a question that spans time scales almost beyond imagining, trillions upon trillions of years. Pondering it can be strangely peaceful, reminding us of the grand time scales at play. It also makes the present moment, the now of the universe, feel even more precious. We are fortunate to exist in a time when stars shine and life blossoms, in a cosmos where so much is happening. Even closer to home, there is the enduring mystery of life itself. We know life arose on our planet, but we don't fully understand how. And we wonder, are we alone in all this vastness? With countless planets circling those countless stars, it seems possible that life has found a foothold elsewhere. Perhaps even intelligent life, gazing at their own night sky, exists somewhere out there. Yet, as of now, we do not have confirmation, just the tantalizing possibility. This too is an unknown that the universe holds quietly. One day, we might learn the answer, or we might not. But thinking about it expands our perspective and fills us with a gentle curiosity about our cosmic neighbours, if they exist. All these mysteries, the invisible mass holding galaxies together, the unknown force speeding up expansion, the unfathomable depths of black holes, the questions of origin, fate, and life beyond Earth, they do not diminish the beauty of the cosmos. If anything, they enhance it. There is beauty not just in what we see, but in what we sense at the edge of understanding. Just as a silent forest at night is made more enchanting by the awareness of unseen life in the shadows, the universe is more enchanting, knowing that there are unseen elements and unanswered questions woven through it. It's comforting